Hey everyone, and welcome to the internet. So what we're going to be doing today is having a look at the process of electroplating. So hopefully by the end of this you're going to be able to describe how we carry out the process of electroplating and also how we use this process of electricity to then purify certain metals as well. So to start us off for today's lesson, then we've got 3 questions on the screen based around our previous lesson. So in your books, have a go at writing down the answers to those 3 questions for me. So I'll just give you about 3 minutes to get that done. Off you go. Okay, so let's see how we did here. So our first question then, explain what is meant by the phrase inert electrodes. Then an inert electrode is one that remains unchanged during the whole process of electrolysis, or we could have described them as being unreactive. Number 2, are 4 metals less reactive than hydrogen are copper, silver, gold and platinum. Obviously tick these if you're getting them right. And then number 3, if we carry out electrolysis of a solution of silver nitrate, what will we make at the 2 electrodes? At the anode it will be oxygen because we don't have a halogen present, so therefore it will be oxygen. And at the cathode we would make the silver because silver is less reactive than hydrogen. So add them up, let me know in the chat window how you did. Who got 3 out of 3, who got 2, who got 1, and hopefully no one got 0. So the first part of this lesson, what we're going to look at is a process called electroplating. Now, the first thing we need to know is that when we're carrying out electroplating, the electrodes that we're going to use will be different to the ones we've used in electrolysis up to this stage. Now, what we usually use in electrolysis are inert electrodes, i.e. ones that will not be changed. But when it comes to electroplating, then we want them to be non-inert electrodes. We actually want these electrodes to change during the process. Now, When we're electroplating something, then what we're actually doing is we're using electricity to coat a metal onto the surface of another object. So what we actually set up is something a little bit different. Our cathode is actually going to be the object that we want to coat with our metal. So you'll pick something like a ring, for example, and that will be connected to that negative terminal. The anode, the positive one, this is going to be made of the metal that we want to coat the object with. So if we wanted to silver plate, then we'd have a silver anode because we'd coat it with the silver. And then finally the electrolyte, this is a solution, but it's got to contain the ions of that metal that we want to do the coating with. So whatever your anode is made of, your electrolyte must be a solution that contains that same metal. If it's not, it doesn't work. So cathode, the object we want to coat, anode, the metal we want to coat the object with, and the electrolyte is a solution containing the ions of the coating metal. So I'll just give you about another 30 seconds to jot any of those points down you don't already have. If you still need a bit more time, hit pause now. Okay, so let's have a little look at what this really looks like in terms of my amazingly drawn diagram for you there. Now, what we can see is on that right hand side is our setup. So we've got the anode, the positive one on the right there, and that's going to be made a block of silver in this case. Then we can see on the negative electrode, the cathode, if you come down to the bottom, you'll see there's a little yellow circle there, which is of course a ring that we are going to cover with silver. Then our solution, that blue sort of stuff there, that is our electrolyte, which is made of silver nitrate in this case. Now the reason it's got to be silver nitrate is because we're going to be coating with silver. That's the same as the anode. So obviously the solution must contain those metal ions, the silver ions, so silver nitrate is what we use as the electrolyte. Now that's our typical setup, and then when we flick that switch, what's going to happen is we're going to transfer the silver from the anode across to the actual jewellery itself, the ring. And it's then going to be attracted to the surface, be deposited there, and we're then going to get this layer of silver on the outside of that ring. So this is how, when we're buying things like white gold jewellery, for example, then this is the process that will make it. Because if you wear a white gold ring, chances are over time you're going to need it replated. Because what actually is yellow gold, so the typical gold that we all know, that yellow colour, which has then just been plated with a different metal on the surface. So when you wear it for a long time, and obviously it moves and you get friction, then it knocks that plating off and the yellow starts to come back through again. So when we are plating things, it's literally just sticking a bit of metal on the outside. That's literally what we're doing here. So one of the things that they could ask you to do as a question is they're going to show you a diagram, rather like this, of our electroplating, but they're going to ask you to say why this won't work. So if we have a little look, basically what we're doing is we're identifying anything that's going to stop the electroplating process from taking place. Now, one thing to look out for is any of these regions, like down here, where we can see that our circuit isn't actually connected onto whatever we're meant to be plating. So if that's not connected, clearly that's not going to work. So there's our first problem. The second one we've got is up here. Now, hopefully we remember that when it actually comes to drawing more than one cell to make a battery, then they always need to have the same orientation. So it has to go big line, little line, big line, little line. Whereas here, what we can see is you've got the two little lines next to each other. Therefore, this isn't going to work. So there's our two reasons on this diagram as to why it doesn't work. just keep your eyes out for questions like that because they're quite easy to get the marks on. Okay, your turn to have a go at a question then. What I've given you is a little diagram there. What I want you to do is look at the diagram and just in your books write down 2 reasons why the ring would not be electroplated. So I'm just going to give you about a minute to answer those 2 points in your books. Okay, let's see how we did on this one then. So, first one you could have written down is that if we look at the 2 cells, then they're in opposite directions. So you could have put that one down first of all. The second one that you could have said is that we've got water as our actual electrolyte rather than something containing the silver ions. So those are your 2 you're looking for, that we got water as our electrolyte, won't work because it's not containing silver ions, and the 2 cells in the battery are facing each other in the incorrect order. The next thing we need to do then is actually explain what's happening. So we've now got the basic idea of electroplating and what it is, that we know that the metal is going from the anode to be deposited onto the item connected at the cathode. We need to add a little bit more detail than that just to make sure we get all the marks possible if they were to ask us to explain the process of electroplating. So what we actually see is something very similar to what we discussed in electrolysis. So where we've got those ions that are attracted to the electrode, then they become discharged. Now what that means is that they're going to be gaining electrons and therefore becoming the neutral atoms which are attached to the surface. So what we actually find when we're talking about the electroplating is the metal ions from the electrolyte are discharged on the surface of the object, but we're then going to have those replaced by metal ions leaving the anode. So what we actually see is that that anode is going to get smaller and smaller the longer the process runs for, because the metal atoms that make up the anode are obviously being changed into metal ions and released into the electrolyte. So each time that happens, the number of metal atoms left on our anode decreases, so the size of it will decrease. And eventually we get to a point where the anode is completely used up, and we've obviously got to replace that on a regular basis when we carry out this process. And remember, the reason it's used up is because it is what's called non-inert, so it is going to react during this process. So make sure you've got those 3 points written down if you haven't already. I'll just give you an extra 20 seconds just to get those done. To add the final bit of detail then, what we need to do is understand the half equations that are occurring at the anode and at the cathode. So if we start at the anode first of all, which hopefully we all remember is the positive electrode, then we start off with silver atoms, so that's made of pure silver. Now what happens there is when the electricity is flowing, those silver atoms lose electrons to form silver ions. And you can see the half equation at the top of the screen there. So silver has the symbol Ag, and it is a solid at that point, hence our state symbol of the S in brackets. Then as the electricity flows, we're going to form silver ions, Ag+, and they're being released into solution, so they get the AQ state symbol, and we're also going to have an electron, E-. So that's what's going to be happening at the anode first of all. Then on the other side of our tank we've got our cathode, the negative electrode, and this is where the silver ions will gain electrons in order to become silver atoms again. So our silver ion, Ag+, is then going to gain one electron, E-, to form Ag in its solid form, so silver in its solid form. So that's the process of the discharging happening at the cathode. Now, the reason that they can do this is because when they're actually released at the anode, those silver ions move through the electrolyte and the electrons are going to be moving through the wires between the two electrodes. Because hopefully we know from our physics that when we're talking about a current flowing through a circuit, it's actually talking about the movement of those electrons. So the electrons flow through the wires in our circuit from obviously the anode to the cathode, and then they're going to be picked up by the silver ions to form the silver atoms again. So again, I'll just give you an extra roughly 20 seconds to jot down any points you don't already have there. Okay, time for you to have a go at a couple of questions for me. So in your books, write down the answer to these two questions. What type of reaction is occurring at the anode, and what type of reaction is occurring at the cathode? So just 30 seconds, have a go at writing those answers down for me. Let's check our answers then. So hopefully we said at the anode we have an oxidation reaction, because remember our silver atoms are losing electrons. So that means oxidation, oil rig oxidation is the loss of electrons. Whereas at the cathode it is a reduction, because those silver ions are gaining electrons, so reduction is the gain of electrons. So tick those if you got them right. Let me know in the chat window who got 2 out of 2. What we're going to move on to now then is the second way that we can use electricity with our metals, and that is in purification. Now, what we actually find is that when we extract copper from the ground, then what we end up with isn't something that's pure. Now, if we don't have pure copper, it's a bit rubbish at conducting electricity, to be honest. So we want the pure copper to really give us a strong electrical conductivity. So what we need to do is purify that impure copper, and the way we do that is by using this process of electrolysis. And what we're going to do is have a look to see how this process works. So first things first, let's start off with those key facts. What's the anode, what's the cathode, what's the electrolyte? So we're going to focus on purifying copper at this point. So the anode is going to be the impure copper, so the copper that's got the impurities still present. The cathode is made of a piece of pure copper, and then our electrolyte will be copper sulfate solution. Now in this case I've just given you copper 2 sulfate, so that would obviously be made of Cu2+ ions. Now what I want you to do is just have a go at writing down, based on all of the work we've done to this point, what you think is going to happen in this process. So you've got the anode, the cathode, and our electrolyte on the board there. What I want you to do is have a go at telling me what's going to happen in this process. So I'll give you about 3 minutes to write down your answers in your book. Try to use as much detail as you can. If you need any hints and tips, then ask in the chat window. Off you go. If you need a little bit more time, then hit pause at this stage. So if you look at the bottom, you can see that I've given you a little diagram of what this would actually look like. So you can see on the right hand side of the diagram, we've got our impure copper anode, and then on the left hand side, we've got the pure copper cathode. And then we've got our copper sulfate solution, obviously, as our electrolyte there. Now, what we know, hopefully anyway, is going to happen is that as our current is flowing through this circuit, then our impure copper anode is going to release copper ions into our electrolyte, and then the electrolyte ions are going to move across to the cathode where they become discharged. Hopefully we've got the basics of this here. Now, what we're actually going to need in our answer, first of all, and tick any of these points that you've got, is that copper atoms are going to form copper ions at the anode. So if you've got that point, give yourself a tick in your answer. If you said that to form those copper ions, the copper atoms will lose electrons, give yourself a tick for that. If you then went on and said that the anode is going to decrease in mass, give yourself a tick for that bit. Then if we said that the copper ions move through the electrolyte, tick for that one. And if we said that at the cathode, the copper ions are discharged, give yourself a tick. If we said that the copper ions are going to gain electrons, give yourself a tick for that bit. And then if we said that the cathode is going to increase in mass, give yourself a tick for that as well. The only other point that I've got on the screen there for you is just telling you the fact that any of those impurities from our anode actually just kind of sink to the bottom of the tank, and they gather as this delightfully named sludge at the bottom. So only the copper ions are going to be moving across our tank to be deposited at the cathode. So remember, the anode decreases in mass, the cathode increases in mass. But not by the same amount, because remember, our anode also has other elements present there that are just going to sink to the bottom. So the anode will lose more mass than the cathode increases in mass by. Okay then, last thing to have a go at today then is a potential example of a 6-mark question. So potassium chloride, KCl, is separated using electrolysis. Describe the process of electrolysis and identify the products made. So what I want you to do is have a go at finishing off this question in your books, and once you've done that, then the answer will be on my website, and the link for that will come up at the end. I'll leave this slide up for a little bit of time now, so give you about 2-3 minutes, but if you still need more time, obviously you can just pause the video. Don't forget, as usual, you can find the answers to the plenary, some additional work and general other resources on my website. The link is on the screen there for you. Hope you found today's lesson useful, and I look forward to seeing you again next week.